In this lesson, I'm going to present evidence that supports the reactivation hypothesis. And this hypothesis says that retrieving a memory requires reactivating the neurons involved in storing the memory. And so this idea was summarized in an earlier lesson on what's happening when we learn information. Our brain is encoding the information, we're storing the information, and then retrieving it. Well, the first line of evidence comes from single neuron recording experiments. Here we have the right hemisphere of the human brain, and underneath the temporal cortex is a structure called the hippocampus, known to be critically important in forming new memories. And here, this blue little spot here will be a single neuron in the hippocampus. And what scientists did then was they were recording from a single neuron, and they wanted to see whether they could find some kind of stimulus that would activate this neuron, during some learning event, and then ask the patient later on to remember that event, whether or not this neuron would be reactivated. If so, that would be direct evidence for the reactivation hypothesis. Now, the neuron that they actually recorded from that you're about to see was located in the entorhinal cortex. This is the area of the brain that provides a major input to the hippocampus. But the pattern of activity of this neuron in the entorhinal cortex is thought to be similar to the kind of pattern of activity that you would find in the hippocampus. In other words, the way the entorhinal cortex neuron will respond, it'll respond to a learning event and then be reactivated upon retrieval, is thought to also occur in the hippocampus. So I'm going to situate the neuron in the hippocampus, even though it was really in the entorhinal cortex. So the scenario of the experiment went like this. You had the patient here with electrodes in their brain recording from a single neuron in the entorhinal cortex, but I'll call it the hippocampus. And then they're going to present to them various video clips. So that's a visual stimulus and an auditory stimulus. There was sound to the video clips. It would be little sections of movies and things, and I'll show you the clip in a moment. Then they're going to, hopefully they play something that activates that neuron. Then they're going to do a distractor task for a little while, and then they're simply going to say to the patient, what do you remember seeing? So here is the recall stage of the experiment. And the question is, if they find some stimulus that activates the neuron, will it be reactivated when they retrieve a memory of that learning event? All right, you're going to hear the voice of Itzhak Fried, and then you're going to hear little audible clicks, and that will be the neuron that they're recording from. Whenever it makes an electrical signal, you'll hear it audibly as a little click.
Video number 1, essentially, you can hear the firing. This is the firing, okay?
Welcome to Wall Street and the New York Stock Exchange, the world's largest, and surprisingly one of...
Hey, Dad! Right on time.
Get out of here. Now, jump in, Mark. Trust me.
So the question is this, because the patient remembered something? Well, we will see that it happens the same. Is it reproducible for this particular stimulus? And there are many videos in between these two, okay?
All right, so what we just saw then was that a clip of The Simpsons activated the hippocampal neuron. They got lucky. They found some kind of stimulus that activated that hippocampal neuron. Now let's remember, though, there were lots of other video clips there, and this neuron was quiet for those other video clips. It did not respond to the Titanic. It did not respond to Dr. King. It did not respond to Sex and the City. But presumably the person could remember all those things. So the idea is some other neurons were involved in making memory traces for those other videos. So it just happens they were not recording from other neurons, just this one neuron that responded to The Simpsons, but there would have been other neurons that responded to the Titanic clip and other neurons that responded to Dr. King or to Sex and the City. So our brain is wired up so that whatever it is we see and hear and so on, we can make memories of those events. We have neurons that will respond, neurons that can grow stronger synapses to form a memory trace, and those neurons can be reactivated when we retrieve. Now the question is going to be, will that same neuron then be reactivated? So when the person is sitting quietly remembering the video clips they saw, will this neuron be reactivated as they experience the retrieval of the Simpsons memory? Let's take a look. Okay, now they're going to show us what the neuron is doing during the free recall session. It's a little hard to hear the patient, but the patient's going to be telling us what it is they're remembering.
That's a memory coming out, something about New York, right? Single cell.
Hollywood sign.
Okay, the cells start firing and the recollection comes and continues to a certain point.
Okay, so what you saw then was that this same hippocampal neuron that was activated when they saw The Simpsons the first time got reactivated when they retrieved the memory. In fact, the neuron became active prior to the person telling us that they remember seeing The Simpsons. It's as though this neuron was being reactivated and was part of that network of neurons that constitutes the memory for seeing The Simpsons. So this neuron reactivated, and then the person said, yes, I remember seeing The Simpsons. What happens when we retrieve a memory, we're going to reactivate the memory trace, those network of neurons that stored the information, and then those neurons will communicate with the working memory system. This is sort of a short-term memory buffer, and then we will have the conscious experience of retrieving a memory. We'll say more about this working memory system in other lessons. So here we have direct evidence then that the neurons that are involved in processing and learning about an event are being reactivated when we retrieve that information.